go ahead and give us a test.
Test. Test. Okay. Are we ready? Okay. So good evening, everyone. I want to welcome you to the SM-1A update on the decommissioning and dismantlement of the former site. So this is a hybrid meeting, so we are virtual on the internet. So if those of you who are joining us virtually have any comments, please drop them in the chat. Other than that, we'll go ahead and get started. Oh, I'm like, next slide. The purpose of tonight's meeting is to provide an update and status on the SM-1A decommissioning and dismantlement. Over the past year, we've had a lot of significant accomplishments at the site, so we want to bring you up to speed on those, as well as provide a detailed forecast of our upcoming work and our path to completion at the site. So we are entering the next phase of the site, our next phase of the work, which is our complex decommissioning. So we will be highlighting the steps that we plan to take, including our safety and regulatory compliance requirements throughout the remainder of the project. And again, our goal is to transparently share updates to keep the public and the garrison informed. So I'm Brenda Barber. I'm the National Program Manager. Jeff Hillebrand is our Project Manager. Dave Waters is our Radiation Safety Officer. And Zach Craven is my on-site health physicist. So tonight we're going to go over an introduction and some background. We're going to highlight our progress and achievements over the last year, talk about next steps, and then provide an overview of our radiological and safety programs, as well as our waste management program, and then briefly touch on public involvement. So with respect to the operating history, we've gone through this a lot here in the garrison, but we wanted to highlight it again. The SM-1A was built from 1958 through 1962. It was constructed as part of the Army Nuclear Power Plant program. It was a single loop, 20.2 megawatt pressurized water reactor, used highly enriched uranium dioxide fuel, and it provided both electrical power and steam heat to the installation during its operation from 1962 to 1972. During that time frame, the core was only changed 4 times. So obviously from an efficiency perspective, it did what it needed to do. And then it was also utilized as an in-service test facility to see how reactors would function in an Arctic environment. Due to regulatory changes in the early 70s, the program began to be shuttered. This particular reactor was shut down in 72 and then deactivated from 73 to 74. All the fuel run, fuels, and some of the waste were transported to the lower 48 states, and the remainder of the waste was left in the encased areas. So the site was placed in safe store, which allows for radioactive decay of the materials, which makes our current efforts much safer for our crew. And from 74 until we started active work at the site, USACE did inspect and perform monitoring at the site in accordance with our permits. So we have made a lot of progress at the site. So since we last met, we have completed the construction of the waste storage area. And so these are now fixtures on the garrison. You can see them from the Richardson Highway. So this is an area located approximately half a mile from the site where we store all of our packaged waste and we ship all of our packaged waste from. We did this primarily to limit constraints within our site at 606 North because it is a very small site. So this area is secured from a radiological and physical security perspective. And we do store roughly 50 containers out there. Right now we've got approximately 11 because we're in a construction phase as opposed to a decommissioning phase. So this will pick back up as we progress this year. Other objectives, we established our environmental and radiological monitoring around the site as well as at the waste storage area. So in the left photo there, we have our what we call dog houses. So that's our radiological monitoring. It has a low vol pump in it. Our radiation control technicians check that daily, and then they collect samples from it weekly. The small green light is an indicator that it is functional and operating. So it's always a good visual for anyone on the team to know if that is working or if we have an issue. We also began to set up our trailers and our power and our fencing and security at 606 North. That's evolving and changing with our ongoing activities, so it doesn't quite look that way today. The first phase of decommissioning actually started in October of 24. Prior to that, we were inspected by the Army Reactor Office, who is our regulator, and they deemed us ready to start decommissioning. So the first formal decommissioning was the abatement and demolition of J5. It's an old Quonset hut that was present on the site and supported the reactor operations. So that has now been abated and demolished very quickly. And you can see in the lower photos, it's just a surface grade area at this point that we use for storage and support of the site. In addition to that, we did sample and characterize the interstitial space in the dome of the vapor containment structure. So there is an outer and inner wall of the vapor containment structure, and we wanted to make sure that there was no contamination or concerns from a safety perspective in that area. So we did sample that for the safety of our crew. Next large effort for the team was to abate all the environmental hazards within 606 North. We do share a common wall. Well, we did share a common wall with the central heating and power plant. So in the upper left photo, you can see that the team began to abate that, remove the environmental hazards associated with that wall in the first two photos there on the left. And then we put up some separation to make sure that we didn't impact the central heating and power plant and they didn't impact us. In the upper right photo, the team is abating some of the overhead utility lines that ran through our portion of the building. And then in the lower right photo, the outer exterior siding was not asbestos, but the original siding underneath that was asbestos. So we did have to strip all the siding off the building to abate the underlying siding. So that was done prior to the start of any of our demolition activities. While we were doing abatement, we also kept the crews very, very busy with other work to remove any environmental hazards. So the demineralizer room, which is just adjacent to the vapor containment structure, and then what we referred to as cold storage, which is actually the encasement of the original hot waste tanks associated with the reactors. The teams went in and did abatement and radiological cleanup and waste removal in those rooms to ensure that we didn't run into any environmental hazards as we demolished those areas. So cold storage, simply we removed the structure above grade. That was about the extent of our demolition and abatement. There were no hazards in that area. But as you can see in the photo on the right, the demineralizer room was filled with all of the remaining waste and debris that the Army encountered as they were leaving the site. So it was a catch-all of everything. This meant that the team had to manually shovel through this area and move this waste out very meticulously. That was all done with no safety or radiological issues throughout that process, and it made it safer for us to implement some of our future decommissioning work. So once all of the siding was off the building and all the environmental hazards had been abated, we moved into active demolition at the site, which I'm sure all of you on the garrison saw. So Northwest Demolition was brought on as a part of our team and began to meticulously demo the building from the north to the south. And we have a video of that so that you guys can see what transpired during demolition. So as you can see, that is where the secondary side was. All that large equipment was pulled down to the ground level surface so they could containerize it and package it. You can see that they're running misting to control dust and any emissions from the site. We also had perimeter air monitoring for radiological as well as dust and silica if that were to be generated as part of our activities. And then once they got near the common wall, the demolition, although it's very quick here, slowed so that they could make sure that there were no impacts to the central heating and power plant as they meticulously removed the remaining portion just adjacent to the power plant. All this waste was properly packaged, moved out to the waste storage area, and then shipped off-site as part of the effort. So once dismantlement of the building was completed, because Northwest Demo had the proper equipment here, and we had done that characterization that I spoke about earlier, they began to demolish the outer vapor containment wall and the steel dome. So what you see at the end of this video is what remains inside the weather enclosure to date. Okay. All right, what did I do? Okay, sorry. So going back to that steel structure, so as I indicated, there's an outer and an inner wall. So Northwest Demo has demolished the outer wall, including the wood facade and the steel dome that you see in the photo to the left. So what does remain is the inner vapor container and the liner around it, and that's what we will be removing the reactor components from in the future. So as you can see, that's just additional photos of the demolition of that outer vapor container wall and removing the steel liner that lined the inside of that. So it did create a moat, an interstitial space during the operation of the reactor. So that is an ongoing remediation effort for us to address. And then we also went back inside the vapor container as part of our efforts to do some additional surveys and characterization efforts to inform future decommissioning and to allow us to design the shielded shipping container for the reactor pressure vessel. Once all of that was completed, the team realigned and reconfigured the 606 North area, and we mobilized a crane and began to build the steel structure. So the steel structure is complete. The foundation was built to support that. We have installed the fabric on the outside of the weather enclosure at this point, and the crew is continuing to insulate it and install an interior liner, and then we will install some more permanent ventilation and lighting. So if you walk by the site now, or if you're near there, you can see that the weather enclosure from the outside is fully constructed. We have access through garage doors and personnel gates. And then this photo to the right is actually a photo of the inside. So this is the inner vapor container. We've set up some containment and filtration here on the old hot waste tanks area. And then this is the spent fuel pit that remains interior to the weather enclosure. So next steps. We are getting ready to enter into the more complex phase of the decommissioning at the site. And so the first area that we are going to work in is the spent fuel pit. So the purpose of the spent fuel pit was it stored spent fuel materials. So spent fuel was moved via the fuel chute from the reactor inside the vapor container via a fuel chute into the spent fuel pit. There was a second story to the spent fuel pit, which was demolished as part of the initial deactivation. So it's now inside the spent fuel pit as debris. And as I said, as part of the initial deactivation, all the fuel from the site was removed and transported to the lower 48 states. So as we prepare to enter into the spent fuel pit, there's some key safety measures that we plan to put in place. First and foremost, we will be building containment over the spent fuel pit inside the weather enclosure to ensure that there's no release of any type of materials as part of our efforts. That containment will have its own ventilation and filtration system to protect our workers, as well as to maintain negative air in that containment system. as part of our initial characterization and sampling efforts, we have found that the encasement material does off-gas ammonia. And so in order to protect our workers, we will be entering this area in level B PPE. We will be on supplied air, and we are coordinating our readiness and our activities with the Fort Greely Fire Department to ensure not only that we're ready, but they are in the proper posture to rescue us if that need arises. So that being said, the containment area is this area in the red. So we'll have an equipment and material contamination reduction zone. That's where our personnel will enter and exit. And then we plan to work south to north through the spent fuel pit. So we will demolish the south wall and work our way in to remove debris, encasement material. Everything will be properly handled and packaged inside containment, brought out into the weather enclosure, and it may be repackaged at that time. We're going to demolish the entire spent fuel pit to grade, and then we're going to cover it so that we have a safe and stable working environment for future activities. And then we're going to remove the containment associated with the spent fuel pit. We don't plan to do any subsurface work at this time. So this is the ventilation system that'll be used to support the spent fuel pit. So there'll be both HEPA ventilation as well as a granular activated carbon unit before any discharge to the environment. And so we've been coordinating those discharges with ADEC to ensure that we're in full compliance. So once the spent fuel pit is completed and demolished to grade, our focus is going to shift to the inner vapor container. So the inner vapor container houses all of the primary reactor components. It is a very robust container. It's 28 feet tall, 3.6 inch or 3.5 feet thick walls, and the roof of this structure is actually 4 feet thick. So obviously a lot of concrete that we're going to need to work through. This has the primary shield tank, which houses the reactor pressure vessel. It also contains all the reactor coolant pumps, the steam generator, the pressurizer. Everything associated with the reactor operations was left in the vapor containment structure. Some of it was knocked down to the floor and is in the encased materials in order to minimize dose. So we're going to work through all of that encased material to remove these components as we work our way into the inner vapor container. So based on all of our entries, these are just some photos so that you guys can see what you would see if we walked in there. What you see there on the right is the upper portion of the primary shield tank, which houses the reactor pressure vessel. And then this is the remaining portion of the steam generator. So the steam generator was cut in half, again, to minimize dose. The part of the upper portion of the steam generator was dropped to the floor and is in the encasement material. So this is really all you see when you walk in. There's a set of stairs, and there's a reconstructed platform at the top of the primary shield tank that we have built to make sure that our crews are safe when they have to access that area. So again, similar to what we're going to do with the spent fuel pit, we are going to build a much larger containment structure to support this work. So the box in red is the containment structure that we're going to build to access the inner vapor container as well as the hot waste tanks. So we're going to build one large containment. Our filtration system in blue will be expanded because of the volume of air that needs to move through this containment. We will probably have 4 GAC units running to ensure safe and regulatory compliant discharge. The green box is the weather enclosure, and then these are connexes with our support crew on the site, as well as some storage to support the team. We will have ventilation through frost fighters stationed here, and then it's very likely that we're going to add one on the western side of the site as well, all in order to properly ventilate the area and protect both our crew as well as the garrison community. So once containment is built, the team is going to create a very large access opening through the concrete. So it's going to be about 1/3 of the inner vapor container will be opened. The first item that we plan to remove is the steam generator that you saw in the prior photos. We're then going to work our way through the primary shield tank to get all of the encasement that was placed in that primary shield tank removed. And then using heavy equipment to include excavators, we're going to start to remove the grout and encasement material, which will give us access to all the components that were left in the vapor container. This will then give us access to the reactor pressure vessel pit and, in the future, the reactor pressure vessel. So we do have a video of this, but we wanted to make sure we pulled out some snapshots. So as I indicated, there is some concrete left around the inner vapor container. So the first thing we're going to do is demolish all that remaining concrete so that we have full access to the vapor containment structure. Once that's done, there's a steel liner on the vapor containment structure, so they have to cut all of that steel lining off so that they can get to the concrete underneath. So that will be our next phase. What you see there is the containment. And then once they have removed that steel liner, they're going to cut a very large access hole in the vapor containment structure so that they can mechanically start to manipulate and move items out of the vapor containment structure. So as I indicated, the first item that we want to remove will be the steam generator, the exposed portion of the steam generator. So they will remove the encasement material around that so we can cut the legs off at the base. So we don't have to cut the steam generator any further. Then they'll then lift and rig that out of the vapor containment structure. It'll be containerized. You can kind of see the container sitting off to the side there. And then moved out to the waste storage area prior to transport off-site. Once that is out of the way, there's some manual labor involved again inside the vapor containment structure. Crews will go in. There is a steel liner associated with the upper portion of the primary shield tank, so that steel liner will be cut away, which will give us access to the concrete that was placed in the upper portion of the primary shield tank. So again, using that heavy equipment, minimizing impact to our crew. They'll remove that concrete structure so that we have a level working space at the encasement level floor for us to proceed. Once all that concrete is removed, about 3.5 feet down, we will find the head of the reactor. We will stop and pause work for a brief period of time to allow both our engineering team and our radiological team to go in and assess the head of the reactor. One, they need to understand how they can lift that properly, so they need to look at the structural integrity of the top of the reactor and see if there's still what we call lifting lugs. And then second, the radiological team will get some additional dose information on it, just to, again, confirm the data that we already have. So once that data has been collected, we're going to resume removal of the encasement material. So we'll break the concrete cap that's on top of the encasement material and begin to mine through that encasement material and encounter some of those reactor components that were left inside the vapor containment structure. If necessary, we do have the ability to put a smaller piece of excavation equipment inside the containment structure. Again, that would be on an as-needed basis, and they would do engineering analysis to make sure that that's stable and safe to proceed. Otherwise, we will continue to mechanically use the larger equipment from outside the containment structure. So once the encasement material has been removed and we removed a majority of the items that were left on the floor, the team's going to shift their focus onto what we call the shield rings that surrounded the reactor pressure vessel during the operation of the facility. They're going to pull those shield rings piece by piece so that they can gain full access to the reactor pressure vessel. So that'll be a long process, but meticulous at best. So there will be some manual labor there as well as some mechanical efforts to remove those shield rings. And once all the shield rings are removed, we will safely lift the reactor pressure vessel it will go into a shielded shipping container and it will leave the base immediately. So we've got about a 48-hour window to get that off base and make sure that it's been transported off site. Here we go. So once the containment vessel is empty, we will install fall protection to make sure that we've properly protected our crew, because that will be a large opening at that point. The team is then going to shift focus to the hot waste tanks. This illustration indicates we're going to pull them through the side. We've actually decided to remove the top of that material and pull the tanks from the top. But they will be, again, secured, lifted, sized if needed to be placed in a container, and then they will be shipped off-site as well. So once all the hot waste tanks are empty and all of the material has been removed from the vapor containment structure, the team will dismantle the containment structure around the vapor containment and the hot waste tanks. Once that containment structure is out of the way, work will proceed under the weather enclosure with demolition of the vapor containment structure and the concrete and floor and slabs inside the weather enclosure. That'll then allow us to begin our subsurface excavation. Like I said, there is considerable contaminated soils at the site, and so that'll be the focus as the team transitions into that next phase, is removal of all of those contaminated soils. Obviously, the weather enclosure will come down and we'll continue to remediate the site until it's fully restored and fully released for future use. So we do have a quick video. Uh-oh. So this video just walks you through everything I just described in the screenshots. Uh-oh. So here they're removing the concrete that remains around the vapor containment structure. Okay. Maybe. Okay, they're removing the steel liner that's on the outside of the inner vapor container. You can see the containment structure is built. They've then opened up the vapor containment structure. And at this point, now the vapor containment structure is open. They have access to remove the steam generator, now cutting the upper portion of the primary shield tank to gain access to the encasement material, which they demolish here. Now they have access to the top of the reactor pressure vessel. The team then transitions into mining out the encasement material and removing the reactor components that were left in the floor and basement area of the vapor containment structure. Once all that's removed, the removal of the primary shield rings will proceed, which then gives us access to the reactor pressure vessel, which will be safely lifted and placed into a shielded shipping container for offsite disposal. Then we proceed to decommission the hot waste tanks, disassemble the containment structure, and then demolish the remaining concrete structures inside the weather enclosure to include the vapor containment structure and all the floors inside the weather enclosure. Then the team's focus will shift to subsurface soil contamination removal. Okay, so next we're going to talk about our radiological protections, safety program, and our waste management program. From a radiological safety perspective, as I indicated earlier, we began formal decommissioning in October of 24, so a little over a year ago. We have a very highly skilled radiological safety team. We've got a lot of health physicists, engineers, technicians. USACE does provide oversight to the entire project. We also have oversight from our regulator, the Army Reactor Office, and the Army Reactor Office has an Army Reactor Council, which is comprised of subject matter experts from the Army for radiation safety, environmental compliance, as well as physical security through the Provost Marshal. We do have a comprehensive radiological training program that the team goes through on an annual basis. From an occupational radiological perspective, we do have continuous radiological job coverage at all times. We do both personnel and occupational air sampling. So these air samplers, again, are at the perimeter. They also do sampling internal at the location of the decommissioning if it's radiological. There are routine surveys performed. We always work with respect to as low as reasonably achievable, which is the Aurora program. So we want to make sure that any dose is always as low as possible. And to date, we've had no measurable occupational exposure at the site. Now, with respect to public and environmental monitoring, we do have 10 of these air monitors associated with the project. There's 8 at 606 North, 1 at our office building just at 609, and there's 1 at the waste storage area. And then we have 29 dosimeters placed around the perimeter of our site. We have a background at our office building, and we have dosimetry at the waste storage area as well. And again, no measurable public dose exposure to date. So this is just a figure highlighting where all of our radiological and environmental monitoring is. These are our dosimeters placed around the perimeter of the primary site. These are all of our air samplers, again, all the way around the perimeter of the site. So we do have robust coverage of the entire work site at all times. So from a safety perspective, key metrics, we've had no lost time accidents or injuries on the project to date. We've worked 550 days since the project began, and over 155,000 hours have been worked at the site. We do have a monthly safety program that we administer with the team. From a safety perspective, we have 3 on-site site safety and health officers at all time, all very highly trained to provide oversight for our crew and to mentor and coach them with respect to safety. So we do have safety as our #1 priority. So some of the key safety metrics that we employ at the job site every morning starts with a daily safety meeting to discuss the job and the tasks that we plan to do. The crews perform a job hazard analysis on a daily basis, and if the tasks for the day change, they stop during the middle of the day and do it again. We encourage employees to participate in this program, provide feedback. We want it to be a very engaging process to make sure that they can speak up. They all have stop work authority, so anyone on the job site can stop the project if they feel that there's a hazard or a risk or just something that makes them uncomfortable and they want some feedback from the management team. Regulatory compliance, I'm always looking at the regulatory framework from a safety perspective to ensure that we're staying up to date with current changes in the industry. Very active training program within the safety environment, always keeping the employees up to date on their safety. We have an annual refresher training that we do every year in January when we return to the site after the holiday break. Risk assessments are done on an ongoing basis, both by the management team as well as by corporate entities that visit, as well as by the USACE oversight team. And then the safety culture, we always promote that safe working environment to ensure that we're mitigating and or eliminating hazards at the site. And finally, with respect to waste generation, to date, we've shipped 140 waste containers off-site. So they do make a 4,500-mile trip to Waste Control Specialists, which is our disposal facility in West Texas. We've shipped 11 drums of RCRA and Tosco waste off-site, as well as some universal waste. All of that has been dispositioned in the lower 48 states, and to date, that accounts for 3.9 million pounds of low-level radioactive waste that's been shipped off-site in full compliance with no issues, both during transit as well as disposal. So for the duration of the project, we anticipate there'll be another 100 to 200 shipments of waste off-site. On average, we were doing 1 to 4 trucks a day. So that's going to fluctuate depending upon the activities at the site. To date, our waste has been mostly demolition waste, concrete, steel, wiring. Our RCRA waste was lead, mercury, asbestos, and the PCB waste as part of our environmental abatement process. This is a low-level radioactive waste as we ship it, but 99% of our shipments to date have been exempt. So the waste is very complicated to get to the disposal facility. So it does leave Fort Greely on over-the-road trucks. It goes into Fairbanks where it's transloaded onto Alaska Rail. It goes from Fairbanks to the Port of Whittier where it's transloaded onto a barge. We then go via barge to the Port of Seattle where we come back onto rail and head to Seagraves, Texas, where we have a short transload into the disposal facility. So public involvement. The purpose behind these meetings is to encourage your feedback and your involvement, and definitely to make sure that you guys are aware of the status of the project and what we're doing. How we're engaging with you. We do update our stakeholders, try to do it monthly, but at a minimum quarterly. We send out emails, and those updates are also posted to our project website. We do have a fairly robust YouTube channel that our team has put together that includes not only videos from SM-1A, but from our sister facility at Fort Belvoir, our SM-1 plant, which is nearing completion. There's a lot of videos of some of this work that's already been completed. There are social media updates posted on the Baltimore District website, and Fort Greely always shares all of that on their social media, so we appreciate that. And then we continue to host public meetings and forums as needed to provide updates to the community. So this QR code will take you to our district website. And as I said, Fort Greely shares all of our information as well. So you have multiple ways to engage. You can also join our stakeholder list and receive emails from the project team with updates. So any questions?
What's the timeline on some of these milestones for the project?
So we are finishing construction of the weather enclosure through the winter. Likely will last into early January. We are hoping to be ready and exercise our readiness with the fire department in the late January timeframe. And then we will be entering the spent fuel pit in that early February timeframe. Depending upon how the encasement material responds to the heavy equipment, we're hopeful we'll be out of the spent fuel pit in about 3 to 4 months. So by the summer timeframe, we're anticipating that we will be starting our efforts to enter the vapor containment structure. That will likely last about a year to a year and a half. And then we'll transition into removal of the remaining concrete structures, the floor, and then the subsurface contamination. So we are still on target to be done in August of 29. And so that's our current timeline. And we're updating our schedule now, so we'll have more schedule details to provide in some of our upcoming monthly updates. Anything in the chat? Okay. Any other questions? Okay.